Okay, Assalamualaikum. Today we're gonna do the lab 4, which is a configuring static and dynamic routing protocol. So my name is Muhammad Rahimi bin Ayub, and my friends is Shahmi Zulkifli and Shahrul Kadir. So next to the topology. Okay, for the lab 4.1, this configuring IAP, Internet Protocol v4 static and default router. So here we can see here have two router and two switch and two PC. So okay, next. Okay, here we can see the addressing table. So we need to insert the IP address into the PCA and PCB. Okay, I already do in a Cisco packet tracker. Okay. Okay, I already configure the basic setting on the router, already done. Okay, and go fast. Okay. Okay, for the step number 3 is to configure the IP setting on the router. So I already configure for the router number 1 and router number 3 based on the question given. Okay, so for the step number 4, so we need to verify the connectivity of the LAN. So I already ping for the PC. So we can see here PCA. So I already ping. So I will get no loss. So okay, for the next one is ping for PCB, PCC. So after I ping, also get no loss. Okay, next is try to test the connectivity by pinging between the directly connected router. So here we can see there are success rate is 100%. So yes. Then I try to test connectivity between the device that are not directly connected. So after I ping, so and then I will get have a loss 100%. So here for PCA, ping to PCC is no, PCA to LO0 is no, and LO1 is no. LO0 and LO1 for the router. Okay. Were these pings successful? So no, the router does not contain router to the distance network. Okay, step number 5 is just need to show the IP interface brief. So here we already show the IP interface brief for the router number 1. So how many interface are active? So I get 2 because here we can see for the IP address. So we can see only 2 IP are assigned for the Gigabyte Internet 01 and serial 001. Okay, for the router number 3. So how many interface are active? So 4. So we can see here the router IP address are active is for the Gigabyte Internet 01 and then serial 000 and then loopback 0 and loopback 1 at the router number 3. So next is C. Okay, for the number C is just want to show the IP route. So I already show the IP route, and then this I already screenshot from the Cisco packet tracker. Then what network are present in addressing table in this lab, but not the routing table for R1. So this the IP address. And then for the next one is the routing table information from R3. So also same for R3 show IP route. So what's network are present in the addressing table in this lab but not in the routing table for R3. So this the 192.168.0.0. And then for the next one is why are all the network not in the routing table for each of the router? So the answer is the router are not configured with static or dynamic routing. Therefore, the router only know about the directly connected network. Okay, for the part number 3 is just to configure the static route. And then for the configure the recursive static route. So for the number A, on the R1, configure the static route for the IP address network using IP address of the serial 000 interface of R3 for the router number 3 and the next hop address. So the command is, so already ni R1 IP route, the IP address and the subnet and the default gateway. Okay, for the number B is the routing table to verify the new static route. So already do. How is the new route is in the table? So here, this is the new route. So I get from this. We can see here at the Cisco packet tracker. And then from the PCA, is it possible to ping the host PCC? So the answer is no. Because of what? Because of the gateway last resort is not set. That's why no. Okay, step number 2, just configure a directly connected static route. So also do the same as given, just this for the router number 3. So this for the IP address, subnet, and this is the number for serial 001. So for the router number 3, also show IP route. So I already screenshot the coding. And then this the how is the new route listed in the routing table. So this the new router. So I get from this. And then from the PCA, is it possible to ping the PCC? So here I already screenshot the ping for the PCC from the PCA. So I'll get loss for 0. So this ping should be successful. Okay, step number 3, configure a static route. So the answer is this is the new on the router number 1. And for the number B is the router on the R3 using the static route configuration option of the previous. So this is a command used in the Cisco packet tracker. Okay, for the next one. Okay, C just need to view the routing table to verify the new static route. After we do for the like above, so this want to show the new IP route. So just for the R1 router number 1, so I write the show IP route. So this the screenshot from the Cisco packet tracker. So how is the new route listed in the routing table? So here I already copy and paste here. So I get from this for here 1 S. So here I get, so I paste in this. Okay, next is for the number D. From the host PCA, is this possible ping R1 address? So this is the IP address. So yes, because of after we ping the IP address given, so we get no loss. So this will be successful. Okay, step number 4 is just to remove the static route for the loopback address. So on R1, use the no command to remove the static route for the two loopback address from the routing table. So I just only put the command for no for on R1. So this a new command. Okay, next. Okay, after I put the no, and then I want to show the view the routing table to verify the route have been removed. So here we can see also same R1 show IP route, and then how many network route are listed in the table on R1. So these 3. So we can see here. And then is the gateway of the last resort set? So also no, because the gateway of the last resort is not set. So already we can see here at the I already screenshot from the Kisco packet tracker. And then okay, for the part number 4, I will give to Shahrul to explain for part number 4. Thank you.
Okay, Assalamualaikum. My name is Muhammad Shahrul. So I'll be explaining about part 4, configure and verify a default route. So it just the continuity from the part 3. So we need to configure R1 router with default using exit interface. Write the command you use in the space provide. So we need to use the command that is given here, and then just plus the serial 0001 here. So this is the thing that we get. Okay, so how is the new route listed on the routing table? So as you can see, I just copy paste this one here. Okay, and then what is the gateway of last resort? All IP packet for which is does not have a learn or static route. So this one, okay, 00 network. So it's static there. Okay, from PCA, is it possible to ping 2006.165.200.225? Yes. So here are the proof, the screenshot here. Okay, 225. So there is no loss. Okay, 198.219 here, 2191. Yes. So there is no loss also. So the ping are successful. So reflection, a new network 192.16x is connected to interface G on R1. What the command could be used to configure a static route to the network from R3. So this is the command IP route 192.168.3.0.255.255.255.0.10.111. So is there a benefit to configuring a directly connected static route instead of a recursive static route? Configuring a directly attached static route allow the routing table to resolve the exit interface in a single search instead of in two searches as needed for the recursive static route. Okay, what is it important to configure a default route on a router? A default route prevent the router from dropping packet to unknown destination. Okay. So for lab 4.2 configuring basic RIP version 2, I will hand over to Muhammad Syahmi. Muhammad Syahmi.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil bin Zulkifli. Okay, for lab 4.2 configuration basic RIPv2. Okay, firstly we need to make the topology that given in the procedure. Okay, for the addressing table. Okay, for the addressing table, we need to insert the IP address for PCA, PCB, and PCC in the topology in the IC packet tracker. Okay, we go to the procedure of this part. Okay, number 1. Part 1, firstly, we need to show the cable. We need to connect the cable like the topology. Okay, step 2, we need to disable the DNS lookup. This is step we're using in the lab 1 and lab 2. And also we need to do the configured MOTD banner, RAM user authorized access prohibited, and insert only lab group X can be accessed this device. Okay, for the step 3, refer to addressing table IP address information of PC. Okay, step 4, we need to test connectivity of the ping. Okay, at this point, PC are unable to ping each other. Okay, this is the first problem that we face. We try to ping PCA to PCB. Okay, next. Okay, number two, configure and verify RIP v2 routing. Okay, we need to configure, check the status of the interface and show the IP interface brief. This is the IP interface brief. Okay, are the relevant interface on each router activated? Yes. Okay, next. As you can see, it's yes. Okay, step 2, view the routing table information for the all router. We need to view the R1, R2, and RT and show the IP root command. This is the This is the screenshot that I screenshot on the IP packet tracker. And step 3, we need to configure RIP v2 routing and insert the coding that given in the procedure. Okay, next. Okay, step 4, we need to view the routing table and verify a new route entry for R1, R2, and R3. This is for R1, R2, and R3 that I took in the IP packet tracker. Okay, this part, check the connectivity between PC. From PCA, is it possible to ping in PCB? Yes. What is the success rate in percentage? As you can see, the success rate is 70% and the loss is 25%. Okay. For the PCA, is it possible to ping to PCC? The answer is no, and the success rate is 0% and there is 100% loss. Okay, next. Okay, next. Okay, this is for PCC. For PCC, is it possible to ping to PCB? Yes, and the success rate is in percentage is 75% and the loss is 25%. And is it from PCC, is it possible to ping in PCA? The answer is yes, and the success rate is 75% and the loss rate is 25%. Okay, next. Okay, C, verify that RIP v2 is running the router. Okay, you can use debug IP root and show the IP protocol and show the running config command to confirm that RIP v2 is running. Okay, the show IP protocol command in R1. Okay, next. When issuing the debug RIP command on R1, the following information is provided to confirm the RIP v2 is running. And when are finished observing the debugging output, issue the undebug all and debug all RIP command. Okay, next. Okay, when the issue show running config on R1, following information provide the confirm RIP v2 is running. Okay, in step 5, examine the automatic submission of root. Okay, the LAN connected to R1 and R3 compose a discontinued network. R2 display equal cost part to the 172.30.0.16 slash network in the routing table. R2 display only measured successful network address 172.0.0.0 and does not reply any subnet of for this network. Okay. R1 display only on subnet 72.330.10.0/25 network. R1 does not have a root. Okay, for R3 only display it on subnet 172.30.30.0/24 network. R2 does not have a root for the 172.30.10.0/24 subnet on R1. Okay, from the debug IP RIP command on R2, R1, and R3 is not sending any command to 172.30.0.0 subnet. Only summarize root of 172.30.0.0 include a subnet /16. Okay, like this. And in step 6, we need to disable automatic summarization. The no auto summarization command is used to turn off automatic summarization in RIP v2 and disable the automation. Okay, now step 7. Assuming the root of table, the LAN is connected to R1 and R2 should not include in along. Okay, as you can see, the IP root for the R1, R2, and R3, and use the debug RIP command on R2 to assume the RIP updates. Okay. Lastly, we need to verify the connectivity and try to IP config simulation to PCB ping from PCA and PCC to 209.165.201.2. And were the pings successful? Yes. And PCC to PCB also yes. Okay, for PCA to PCC also yes. And the ping were 0% losses and 100% successful rates. Okay, the reflection in this part, why would you turn off automatic summarization for RIPv2? Okay, so the router will no longer summarize routes at the major classifiable network boundaries. Okay, this is the last page of this lab. Thank you. That's all from us.